Exam 2, review, question number 1. If the probability of event is equal to 0.46, what is the probability of the complement event? So we know that the probability of the event plus the probability of the complement of that event is equal to 1. Because of that fact, we know that the probability of the complement event is equal to 1 minus the probability of event, which will lead to 1 minus 0.46, and that will lead to the probability of the complement is equal to 0.54, or 54%. Question number 2 is similar. So if the probability of the complement is 0.63, what is the probability of the event? We're going to use the same rule that we used here. So now we know that the probability of the event is equal to 1 minus the probability of the complement event, which is 1 minus 0.63, and that will lead to the probability of the event is equal to 0.37. Probability is always between what two values? Probability is always between 0 and 1. In other words, the probability of any event is greater than or equal to 0, less than or equal to 1. Number 4, an event with a probability 0 means it's impossible. It cannot happen. An event with a probability 1 means it is certain to happen. Number 6, the table below shows the probability distribution of the number of customers in a line for customer service counter at a local Walmart on a Monday morning. We have the number of customers, 0, 1, 2, 3, 4, 5. These are the possibilities for the number of customers, not calls, in line, and then the probability of that number. So the probability of 0 customers is 0.09, the probability of 1 customer 0.15, and etc. What is the probability of 2 customers in line? Because this is a probability distribution, I know that the probability, if I add the probability of each of these numbers, the final answer must be equal to 1. So, to find the probability of 2 customers standing in line, that is 1 minus the sum of all of the other given probabilities.
So 0.09 plus 0.15 plus 0.25 plus 0.14 plus 0.06.
We're going to do the addition first, and then we're going to subtract. So this is going to give me 0.69. And that gives me the probability of 2 is 0.31, which means I can replace that with 0.31. What is the probability of at least 3 customers waiting in line? So at least 3 customers, that means I have 3 customers or more standing in line, because the least is 3, but it could be more. So it could be 3, 4, or 5. So because I'm saying or, in this case, probability at least 3 is equal to the probability of 3 plus the probability of 4 or 5. Okay, 3 or 4 or 5, or means addition rule. So 0.25 plus 0.14 plus 0.06, which will give me 0.45 or 45%. What is the mean number of customers in line for customer service? So the mean for a discrete probability distribution, this is a discrete probability distribution because the numbers are discrete. You can see and count them. So that is a discrete probability distribution. The mean you can use on Excel, the sum product function. And then you can basically select the first set of data. So the first set of data. And then you're going to select the second set of data, which is the P of X. I'm going to try to color code here so you know which one goes where. This this is how you do it using Excel. If you want to do it manually, you're going to multiply x with the probability of that x that corresponds to it, and then you're going to add everything together. So you're going to multiply and then add. So you're going to say the mean is equal to 0 times 0.09 plus 1 times 0.15 plus 2 times 0.31 plus 3 times 0.25 plus 4 times 0.14 plus 5 times 0.06, which is going to give you a mean that is equal to 2.38. So the mean is equal to 2.38. To find the standard deviation, number D, the standard deviation for the number of customers online. So the formula for the standard deviation states that it is the square root of, take the x, subtract the mean from each x, square that amount and multiply it with p of x. In other words, you're going to create a table. In the first column x, the second column p of x. You already computed the mean, so you have your x's 0, 1, 2, etc. And you have the probability 0.09, 0.15, and etc. You're going to create a column here. You're going to take each x, subtract the mean, which is 2.38. We computed it in step number C. Square that and multiply with p of x. And then add everything up. You're going to find the sum. And then you're going to take the square root of the sum to find the standard deviation. So on Excel, it's going to look something like this. So let me just erase what I did here. So we have that table ready. Now I'm going to do that step. So that step starts with, you're going to say equal sign. So you're going to say equal, and then open parentheses. And then you're going to click on the first cell that has x minus 2.38, which is the mean. Close the parentheses, raise that to the second power, and then multiply, so times p of x. So click on p of x and then enter. Now you're going to populate. So let me try to do that again. Fill and then populate. Okay. So now we found that column. All we need to do is just to find the sum. So we're going to say sum of this column, which is 1.1756. And then to find the standard deviation. So the standard deviation is equal to the square root SQRT of the answer or the sum that we found. So that is our standard deviation basically. So again, first you're going to create a table with the x values here, and then p of x here. And then this column is basically, you're going to open parentheses, click on the cell that has x minus, type down the mean, square times, click on the cell, the first cell that has p of x, which is 0.09, populate, add, and then the square root of the sum will be this number right here. Okay, going back here. So the sum was 1.7156. The square root of the sum is square root of 1.7156, which is going to be approximately 1.3098, and that is the standard deviation. Question number 7. In a recent survey conducted by a fitness magazine, it was found that 25% of adults in a certain city engage in regular exercise at least 3 times a week. You decide to conduct a study to collect data from a sample of 200 adults, determine whether the sampling distribution is of those who exercise regularly is normal. Subsequently, calculate the mean and the standard deviation of the sampling distribution. First of all, we have a probability here. However, the sample size is too big to be binomial, so we're going to treat this as distribution of sample proportion. When we discuss distribution of sample proportion, the first step is to check whether it is normal or not using this formula. If n times p times n minus p, or 1 minus p, is greater than or equal to 10, then the population is normal. We have n, which is the sample size is 200, and the probability is 0.25, which is 25%. So we're going to substitute. So 200 times 0.25 times 1 minus 0.25. If you do this on a calculator, you're going to get 37.5, which is definitely greater than 10. So the sampling distribution is normal. We're going to compute the mean of the distribution of sample proportion, which is equivalent to the population proportion. So that is 25% or 0.25. The standard deviation of distribution of sample proportion is the square root of p times 1 minus p divided by n. We're going to substitute the numbers in, so 0.25 times 1 minus 0.25, that's 27%, over 200. You're going to do the multiplication, then division, and then you're going to take the square root. So the answer is going to be approximately 0.0306, and that is the standard deviation. Tom is a music enthusiast with a collection of various albums. He has 8 rock albums, 5 jazz albums, 4 classical albums, and 6 pop albums, and 7 hip-hop albums. We want first to find if Tom randomly selected 2 albums, he puts the first one back before selecting the second. What is the probability that he picks a jazz album followed by a classical album? So before we do anything, I'm going to create a summary here of what I have. So I have 8 rock albums, 5 jazz albums, I have 4 classical albums, I have 6 pop albums, and then finally we have 7 hip-hops. That is a total of 30. So now let's answer the first question. What is the probability that Tom picks a jazz and then picks classical? So this is the product rule, which means the probability of the first times the probability of the second, given that the first event happened already. So given that Tom picked jazz as the first option. In this case, because Jack puts back the first selection, this is not going to affect the second choice. So what is the probability of picking jazz? That is how many jazz albums we have out of the total. Times. Now, Tom is going to put that jazz album back, which does not affect the total, so the total remains 30. Now, what is the probability that that Tom picks classical? How many classicals we have? We have 4. They are intact, and because the total albums did not change as well because of Tom action putting back the album after picking it up. So if you reduce and multiply, I will reduce really quick here. So divide by 5, 1, divide by 5, 6, divided by 2, 2, divided by 2, 3, divided by 2, 1, divided by 2, 15. This is going to be 1 over 3 times 15, which is 45. So that is the probability. You don't have to reduce, but I'm reducing here. If Tom randomly selects 2 albums without replacing the first one back, what is the probability he chooses pop and then chooses rock? So because of this action and, it is a product rule again. So that is the probability of pop times the probability of rock, given that he chooses the first one to be pop. So the probability of selecting the first one pop is how many pop we have, which is 6 over 30. Now, what is the probability that Tom selects rock, given that 1 pop is gone? That is how many rock albums we have. 8 out of how many albums we have in total now that 1 pop is gone? That is 29 in total. So the total went down by 1 because Tom did not replace the first one back. Now, if you multiply, you're going to get 48 over 870. If you divide both by 6, you're going to get 8 over 145. Or you can reduce from the start. It doesn't matter. The next question, number 9. The height of sunflowers in a garden follows a normal distribution with a mean of 120 centimeters and a standard deviation of 15 centimeters. Show all 4 steps. Now we have the first question. A, what is the probability that a randomly selected sunflower is taller than 130 centimeters? So this is a normal distribution. So we're going to first graph the shape. I have the mean in the middle, which is 120. 130 is above that. 130 is slightly above that. The question says, what is the probability that a randomly selected sunflower is taller? Taller means it's bigger. So that is the probability that I'm looking for, which is anything bigger than 130. So mathematically, we say P of X is greater than 130. It doesn't matter whether you put an equal sign here or not, because this is a continuous distribution, which means the area under one dot is insignificant. So the first step is to standardize the 130. So we're going to find the z-score for 130. On Excel, you're going to use the function standardize 130. It's going to ask for the mean, so you're going to plug the mean, comma, the standard deviation 15. Now on Excel, this is how you're going to do it. You're going to say equals standardize. It's the first function pops up, 130, comma, 120, comma, 15. Or alternatively, you can just type them there so you can keep using them over and over again instead of typing them each time. So we got 0.667. We're going to round to 4 decimals. So we're going to round all of the z-scores to 4 decimal places. So this is going to be the z-score of 130 is 0.6667. Okay. So the z-score is positive, which means it's correct because 130 is bigger. So if I want to do this again, the mean will be 0, and then 130 will be 0.6667. We know that because this is the standard normal distribution, so the mean is 0 and the standard deviation is 1. Now, because we want to find the area to the right of 0.6667, we're going to use 1 minus norm distribution because the area to the right equals 1 minus the area to the left, because the distribution function, the normal distribution function, only computes the area below. It doesn't compute the area above, which means it's only going to compute the area to the left, not the area to the right. So in order to find the area to the right, we're going to say 1 minus the area to the left. So 1 minus norm dot S dot distribution of the z-score 0.6667, comma, true. We need to cumulate the area, so we need to add everything down. This is going to give me 0.2525 approximately, of course, rounded to 4 decimals, or in other words, 25.25%. Let me show you on Excel. So I'm going to say this is equal to 1 minus norm dot S dot distribution of the z-score 0.6667, comma, it says cumulative or not, so I will choose cumulative, which is 1, the option 1, and then click enter. So this is approximately 0.2525. You can turn that into decimal after rounding it to 4 decimal places, into a percent after you round it to 2 decimal places. What is the probability that a sunflower height falls between 110 and 140? Same exact thing. So here is the 0 in the middle. We want to find what is the z-score of 110, what is the z-score of 140. So we're going to standardize z of 110, which is standardize 110, comma, the mean, 120, comma, standard deviation. This is going to be approximately negative 0.6667. You can try that on Excel. And then we're going to standardize the 140 as well, or compute the z-score. which is going to be approximately 1.3333. And now, in order to find the area in between, we're going to say the area in between is equal to the area to the left of the big number, so minus the area to the left of the small number. And that will leave us with the pink area. So we're going to say the area in between negative 0.6667 and 1.3333 is equal to, so this is norm dot s dot distribution of the bigger number, comma 1, minus the area norm dot s dot distribution of the smaller number, negative 0.6667, comma 1. We need to cumulate. So if you do that on Excel, you will get equals norm dot s dot distribution of 1.3333, comma 1, close parentheses, minus norm distribution of negative 0.6667, comma 1, and then enter. And that is going to give us 65.63 approximately, or 0.6563. So it's going to be approximately 0.6563 or 65.63%. 60% of the time, sunflowers are shorter than how many centimeters? So basically we have that 60% is above the 1/2. So this is the area, 60%. This is 60%, and there is some z here sitting related to a specific length. So 60% of the time, the sunflowers are shorter than how many centimeters, which means we're looking at the area below that z. So because we have the area to the left of that z missing number, we're going to use the inverse function. If we have the area to the right, then we need to find the area to the left first, and then we can find the area to the right. So the z-score is equal to norm dot s dot inverse of 60% or 0.60. And that z-score will be equal to approximately 0.2533 rounded to 4 decimals. And now, in order to find the x itself, we're going to use this formula, z times the standard deviation plus the mean, which will equal to 0.2533 times 15 plus 120. And that is going to give us approximately x is equal to 123.80 centimeters.